Welcome back, and today we're going to be talking about solving quadratics by factoring. Okay, I had two videos for factoring posted earlier, but right now we're going to be solving quadratics. And before we get into it, we have to understand what that means. Now remember, a quadratic equation, when graphed, is going to look like a bowl. It's either going to open upwards or downwards like this. Okay, it's going to extend forever. Okay, and when we solve quadratics, where we have a y equals ax squared plus bx plus c, when we're solving quadratics, we typically set them equal to 0. So we're going to end up with 0 equals ax squared plus bx plus c. And what that's asking is, where is my y value here? 0 for this quadratic. And what you'll notice is that's actually going to be where the graph touches the x-axis. And usually it's going to be in two places. So when we solve quadratics, we're going to get two answers. Okay? Usually you will get two answers. Now sometimes they could not be real answers. Okay? You'll end up with a negative under a square root. And we'll look at cases of that in later videos. Now let's go ahead and start by picking an equation. And for this example, we're going to look at 5x squared plus 18x plus 9. And we're going to solve that, which means we're looking where that whole thing equals 0. Now, we do know how to factor this, and we're going to be factoring using box method here. Okay, so how do we do that? Well, we know that this trinomial is going to end up factoring into two binomials, so let's make a box. Okay, and the first term here is going to go in the first one. The last term goes in the last box. Okay, and we know that these two boxes are going to add to give me 18x. And we need to know what factor do we need, okay? What number do we need to find factors for? And we're going to find out that by multiplying our first term, the a term, times the last term, the c term, or the 5x squared times 9. And that's going to come out to 45x squared. So I'm looking for factors of 45x squared that add to give me 18. Now, the interest of time, I'm going to go ahead and give you all the answer to this so we can move on for the solving part. But usually here I would start with 1 and 45 and start listing out the factors. I know 2 isn't because it's not even. The 45 here is not even, so 2 is not going to be a factor. But I know here that my factors are 15x and 3x. Those multiply to give me 45x squared, and they add to give me 18x. So let's go ahead and use that one. Okay, so here I'm going to have 15x and 3x. Okay, those are both positive. Alright, so now that I have my box filled out, I'm going to go ahead and look for GCF's terms here for my binomials, or greatest common factors. So let's start with this top box here. What is the greatest common factor of 5x squared and 3x? Well, I know it's going to have an x in it because they both have x. But I'm not sure it has anything else because I don't think there's a greatest common factor other than one that deals with 5 and 3 here. So I'm just going to leave it x. Now let's move over here. I need the greatest common factor between 15x and 9. And I'm pretty sure that's going to be 3. Okay. Now let's look across here. I need the greatest common factor for this space of 5x squared and 15x. That's going to be 5x. And then down here we're looking for a GCF of 3x and 9. I'm pretty sure that's going to be 3. Now, in order to check this, because every once in a while you may make a mistake, I do, I just go through and see if they multiply out. X times 5x is going to give me 5x squared. 5x times 3 is going to give me 15x. X times 3 is going to give me 3x. And 3 times 3 will give me 9. So this here works. The other way you can check it is by graphing both the original equation and the two binomials the factoring gives you in a graphing calculator. And if they end up right on top of each other, you know they're the same thing. Well, now that we have these factors, we can solve this equation, because that's what the video is all about. It's about solving quadratics. We've factored, but now we need to solve. Okay, we have to, in order to do that, we have to go back to what it was equal to begin with, because I know 5x squared plus 18x plus 9 and the two binomials 5x plus 3 times x plus 3, those are the same thing, so they're interchangeable. Okay, so instead of putting this trinomial, I'm going to use this binomial and set it equal to 0, just like the original. Okay, now this is where a special mathy thing comes into play, because what we want to know is, for what value of x is this thing going to go to 0? Okay, and it really doesn't matter which one is 0, because no matter what, if this term here, if this x plus 3 ends up being 0, it doesn't matter what this is, because we're multiplying it by 0. So this term could turn out to be 100, and 100 times 0 is 0. Or it could go the other way. We could end up with a situation where this term goes to 0, and this term is negative 5. Either way, 0 times negative 5 is going to yield 0. So that allows us to set each of these binomials separately equal to 0, and then solve. So I'm going to set both of these binomials, the first one and the second one, equal to 0. And then I'm just going to figure out for each case what x is equal to. Okay? And so for this one, I'm going to subtract 3 from both sides. These 3's are going to cancel out. And then I'm going to end up with 5x equals negative 3. But we're not done, because x still has something with it. So I need to use the inverse functions and get rid of this 5 here. Okay, so I'm going to divide by 5. And I have to do the same thing over here. So we're going to find out that over here, x is equal to negative 3 over 5. Okay? So that's one of my answers. But quadratics, remember, this graph touches the x-axis in two places. So there's two possible answers. Okay? So we have to go ahead and find the second one. So let's go ahead and solve this for 0. Okay, for x. Well, I'm going to subtract 3 from both sides. Okay, and I get x equals negative 3. So my two zeros, my roots, my solution set for this quadratic, those all mean the same thing, by the way. My solution set is going to be x equals negative 3 and x equals negative 3/5. Okay, and that is solving quadratics by factoring. And really, if you can factor, you can solve it.